So solving rational equations. So everybody looking at this word, as soon as you see equation, then you know that it's something with an equal sign in it, and your result of your final step, you should make a statement, x equals something, or if your variable is a, or whatever you have as a variable. Okay, there's two strategies. The first strategy is a cross-multiply situation. Okay, so a cross-multiply situation is when you have one fraction equal to one fraction, and then you make this times this equal this times this. Okay, this strategy only works across an equal sign. Okay, strategy number 2 is you're going to, I call it common denominator drop. If you get this side and this side over the same denominator, to make the sides equal, I just need to make the tops equal. Because if the bottoms are already equal to each other, now I'm just worried about making sure the tops are going to be equal to each other. Okay, 2 examples here. When I look at this, can I cross multiply it or not? Yes or no to cross multiplying? The answer is yes. Why can you cross multiply? Because you have one fraction and one fraction on that side. You have one fraction and one fraction. So you can make this times this equal this times this. Okay, so here I better make the number 40, and then I'm going to have to times it by x plus 1 after. Okay, you see that? That's a 40, and then I still have to go times x plus 1. And here I'm doing a 15 times an x plus 4. Do you see how important brackets are there? Okay, can you do some work there? Okay, when I get to this step, now I'm asking myself, what am I going to do to algebraically isolate or factor or what?
Take away the smaller 6 or 15.
Yeah, this is isolate, so I'm going to group x's together. So I like to get rid of the lowered amount. Okay, so this should be 25x. So once I've isolated the x's together, now I need to isolate the numbers together. So I'm going to minus 40. Divide. So x equals, you can leave it like that, or you could reduce it by 5, so that's 4/5, or I would have been okay as a decimal too. You don't have to write all 3 of those, but I would accept a person who wrote that or that or that. I'd accept all of them. Okay, let's just double check here. Are we allowed to have that as an answer? What am I not allowed to have for x? I can't have x be a -4 or -1. So this is good. It's good. Okay. Number 2. Can I cross multiply? No. Because I have 2 fractions on this side. So therefore I cannot do that. So you can only do it if there's 1 fraction here and 1 fraction there. Okay, so I'm going to set it up like that. So I'm going to try to make everything on this side and this side, I'm going to make the same bottom. So what do I all want in my bottom? So actually I'm first going to go back to this and look at it in factored form. So can you factor that for me? Okay, so if I looked at every single thing on the bottom, right, what do I want my bottom to be? What's the common bottom?
X minus 2.
I need my bottom to have an x minus 2 and an x minus 4 in it. Okay. So I'm going to look at this first fraction. What did I do from this to this bottom? I multiplied by an x minus 4. So therefore that makes x squared minus 4x. Okay, now I'm on to the second fraction here. What did I do from here to here? What did I do to the bottom?
Times by negative, or x negative.
I times by an x minus 2, so that creates a plus x and a minus 2. Okay, now I'm to the other side of the equals here. So this fraction, what did I do to the bottom? Nothing. So I'm going to keep the 2 on the top and do nothing to it. Okay, does this make sense to you? If you have a left-hand side of an equation equal to a right-hand side, and the bottoms are the same, does it make sense we can conclude we just need the tops to be the same now? Does that make sense? Or if you really did this in a long way and you cross-multiplied, do you understand when you cross-multiply that those would get canceled out eventually? Does that make sense as well? Okay, so this is why I call it common denominator drop, because now we can drop that off. So I'm going to make the statement x squared minus 3x. I just put those together. So this top has to equal that top. So the numerator, so that's what I said here, the numerator of the one has to equal the numerator for the second one. Okay, algebra branch. Are you following that algebra branch? Do you isolate? Can you isolate? How many variables do you have? 2 variables. What's the instant first thing you do when you have 2 variables?
Equals 0.
Equals 0. So I'm going to minus 2. Okay, so we got it to 0. Now we look at it. Do we have any of our factoring techniques? Simple trinomial. So I'm multiplying to 4. So 4 and 1. Okay. Now I'm going to go back up here. What am I not allowed to have for an x value here? What? I can't have x be a 2. I can't have x be a 4. Uh-oh. That's a problem, because that's what I told you that I wanted. So now I have to cross that off because it's not a solution. So my solution is just a negative 1.
What would happen if you forgot to cross it out?
Then you'll lose a half a point on a test because you forgot about your restrictions. Okay, number 3. Okay, so the first thing you look at is you say, am I going to cross multiply it or common denominator drop it? Those are your 2 options. Common denominator. So that's what I do as a setup. I'm gonna have this side, the bottoms are gonna be the same. Okay, let's factor that one. So it's a GCF, recognize it? So I'm gonna go X bracket, X minus 2. Okay, so now I'm thinking my common denominator, what do I need to have in there? I need an X and an X minus 2. All right, now we're gonna go through that process of what do we need as a missing multiplier. Okay, so looking at this fraction, it had an X minus 2. Therefore, it got times by a X. So 5X. Okay, next, the 4. So this bottom got multiplied by X minus 2. So the top will as well. Okay, I'm on to the third fraction. This bottom, I did nothing to it, so I'm going to just add 10. Okay, does that make sense? A lot of these things are things we've already done. Okay, if this bottom is the same as that bottom, I'm going to not think about them. I'm just going to make the conclusion this top has to equal that top. Okay, so this is an isolation, right? Because we only have a one variable situation. So I'm going to minus a 4x, and I get x equals 2. Okay, what am I not allowed to have? I can't have x be 0 or 2. That's a problem. That's a problem, so it's not allowed to be a solution. So what should I make as an actual statement when I'm on this question then? No solution. Because I'm trying to say x equals something and x is not going to be able to equal anything. Okay, I'm going to do some in your booklet. So I'm going to pick number 3 and 6 here. So this is now in your work booklet. 3 and
What page?
I'm on page 7. Question 3 and I'll go with 6 after. Okay, good, we found it. Number 3, okay, looking at it, should I cross multiply or common denominator? Cross multiply, so that is going to equal that. Okay, I'm going to write it down like so. Okay, on the other side of things here, you have 3 things going on. You're going to have to do that times a 2 times a that. Are you okay if I multiply this together first and then I would do it times that? So this is 2x plus 4. Remember, when you have 3 units multiplying, do 2 of them, and then by the third. Does that make sense? So I did the 2x plus 4 first, and then I still have to times it by that.
Can I switch the place of the first one?
Yeah, like yours is just backwards like that?
Yeah.
That's fine. So that would be like you doing a 4 times a 5 and me doing a 5 times a 4. We're going to get to this. That's fine. We're going to get there the same. Okay. Foil. Go ahead. First, out, in, last. Got a foil and foil the other side. So you do it. I'll do mine. Okay, how is this looking? We got the same? Foiling's okay? Okay, you know what I see? I see a 6x squared on that side and a 6x squared on that side. What's the algebra behind what's going to happen there? They're going to cancel out. So I could say if I subtract 6x squared from both sides, you can do that, they would be gone. Okay, I'm going to simplify this because I'm going to put that together. So 26x plus 20. And on the right side, I can put the 8x, 12x together, right? All right. Grouping x's together, it's isolation stuff. So put your x stuff together, put your number stuff together. So I'm going to minus 20x. I'm going to minus a 20. Okay, when you're done, you need to go back up to the top and look at it and say, is it good? Does it meet does it pass the restriction test? Are you worried about negative 2/3? Are you worried about negative 2/3? No, it's good. It's not a restriction. Okay, number 6. Okay, so this is number 6 on your page. So first of all, do you think we're going to cross multiply or common denominator it? Common denominator it. So I'm going to factor this. What's the first instinct of the factoring on that? Negative out. So 4x squared minus 1. Now what? Difference of squares. Okay, so we said we were going to common denominator it. So 2 fractions, this side, this side. What am I all going to put in here? I need a negative 1, I need a 2x plus 1, and I need a 2x minus 1. All right, let's talk about what we're missing. So the first fraction, here's the bottom. I did nothing to the bottom, so 8. Okay, next fraction. This bottom would have got times by a -1 and a 2x minus 1. Okay, and this fraction would have got times by a -1 and a 2x plus 1. Okay, so what's going to happen here? Negative subtracting times a -1 over here. Can I cross that off and just put everything's going to be plus then? Does that make sense? So I'm scratching that negative with that negative. It's all going to end up being an added. Okay, so this is a FOIL. You ready? First times first, 4x squared. Outsides make -2x. Insides make -2x. If you're getting good, you might be combining those already. And last times last is plus 1. Guys, apparently I have no pens that work today. This is like my 10th pen. Okay, and this. What do you want to do? Do you want to do this times that first? And then after make them negative? Is that what we should do? Okay, so first times first is 4x squared. But now I got to negate it. I'm sure. Is that skipping too many steps if I do that? Was that okay? I did this times this, but then eventually I'm still going to have to times it by -1. Okay, outsides make 2x, but then I'll have to negate that yet. So -2x. Insides make 2x, but then negative. Last times last is 1, but then I'll have to negate it. Okay. What am I going to get on the top of this one? 0. Because you're, I guess, technically going to times it by all 3 things, but what's 0 times doesn't even matter, right? 0 times a bunch of things, it's still 0. Okay, simplify this. 4x squared subtract 4x squared. Cancels. A 1 subtract a 1. Leaving me with 8 subtract 8x equals 0. Okay, now I'm going to isolate, so I'm going to add 8x. Move my x's and numbers away from each other. Divide by 8. So x equals 1. So is this okay? Is it a problem with our restrictions? Do you see any restricted ones? It's good.